All right, we've reached the lesson 9.5 where we're actually going to start showing what the graphs of sine, cosine, and tangent look like. And there are graphs of the reciprocals of those as well, but we're just going to focus on these three. So we'll start with the graph of what we call the parent of these three, and then we'll look at some basic transformations at the end of the lesson. So let me show you first of all. We'll start with the parent sine function. Y equals sine of some angle called theta. And I'm going to show you the graph of what sine looks like, and then we'll come back after we've looked at the graph and we'll fill in this particular information relating to the sine function graph. Okay, well, here's the way we'll set this up. And when you do your homework problems, you'll do the same thing. Your graph is actually going to go on this deal right here. We have a horizontal axis, which we typically look at it as the x-axis. Technically, it's going to contain values for theta, some angle measurement in degrees. So I'm going to label that as the theta axis, and this vertical axis will be the y-axis. And I'm going to put theta in terms of those four quadrantal angles that we look at on the unit circle. So just going in a positive direction, we come to 90 degrees, and then 180 degrees, and then 270, and then 360. And that's really all we need. We're not going to worry about graphing all of these in the positive direction. Let's just walk our way through this, and then you'll see how this works. This starts off at theta being 0 degrees. So looking at your unit circle, if you go to the 0 degree angle and you evaluate sine of 0, you're thinking, okay, sine is the y coordinate for that ordered pair. So sine 0 degrees should be 0. So it's like this. I input 0 for theta, my output is 0 for y, and so I get the point 0, 0. Okay, I move down to 90 degrees and just think input 90 degrees in for theta, evaluate sine 90 degrees. Well, you go up to the 90 degree angle. Once again, you take the y coordinate for sine. The y coordinate for that 90 degree angle is 1. So when I input 90, I get output 1. Moving over to, yeah. Do you have your units? Okay, let's move to 180 degrees. Evaluate sine 180. If you look at your unit circle, the y coordinate for that ordered pair at the 180 degree is 0. So once again, when we input 180 degrees, we get an output of 0 for y. When we go to the 270 degree angle, that's down on the negative y-axis. The y coordinate for that angle, sine of 270 degrees, is negative 1. So we're going to make input 270 degrees. That means the output will be 1. And now we're all the way back around the 360 degree angle. The sine of 360 degrees is 0. And so we just use a curve. These are not V shapes. These are curves connecting these dots. And I'm going to just show it's going to go up to that point. Now, it's not going to go above 1, and over here it's not going to go below negative 1, but at least it's going to keep on going a little bit more and then turn. Okay, so we would call this the parent sine function. And so let's identify some parameters, some particulars. The domain, and we always think about the inputs, what are allowable inputs for this function, and it's really any real number, any number in degrees or radians for that matter, that could be substituted in for theta. So It's just all real numbers. As long as it's a real number, it's fine. The range, however, it's only going up to +1, no further, and we're not going below -1, so it's all the numbers in between. So we'll state the range, all y such that we're between -1 and +1. Okay, let's talk about amplitude. If this were a real-life function, it could be describing something like sound. Sound waves travel like this. Amplitude, if we're talking about sound waves, determines volume. So the higher the sound, the larger we would spike, either up or down. Okay? Smaller, if we reduce the sound, then it would be closer. So the amplitude for this particular function is 1. And you can get amplitude by looking at the number in front of sine and just taking the absolute value of that. Well, there's an understood 1 here as a factor, and so that means that is my amplitude. If this said 4 sine theta, then I would have a 4 up here, and I would have a -4 down here, and the amplitude would be 4. It's pretty simple to determine amplitude. Just look at whatever's in front of sine or cosine. Other real-life applications of this, blood pressure. Really common in the medical field because the increase in blood pressure is when the heart pumps blood out. And then there's a time after the heart pumps. I mean, the heart is a periodic function. It's basically doing the same thing. Hopefully it's doing the same thing all the time. Just pumping and then it's collecting. Pumping, collecting. So this pumping action would be an increase in blood pressure. That's called systolic. And the collecting of blood, which is a decrease in blood pressure, is diastolic, I think, diastolic. And so this is a real-life picture of actual events. This is a model of things like blood pressure or anything in real life that repeats the same cycle over and over and over again. Even something as simple as pedaling a bicycle. It's that same repetitive motion, starting at a starting point, going back to that, and then repeating. Okay, so the amplitude is 1, and the period we've already talked about. The period is the length, the horizontal length of one complete cycle. And this starts to repeat after 360 degrees, so that is our period. Okay, so that takes care of sine. Now let's take a look at cosine. Very similar. Slightly different. We'll go ahead and label these as the quadrantal angles again, 90, 180, 270, and 360. This is for theta inputs. This is our output, y. So let's start with angle 0. So John, you're looking at your unit circle. If I input 0 in for theta, in other words, I'm going to find cosine 0 degrees. What is the x-coordinate for the 0 degree angle? Should be right there on the unit circle. What's this point? 1, 0. Okay, cosine relates to which of these, x or y? We've got to nail this down. Exactly. Cosine is the x-coordinate, sine is the y. So when I ask you what is cosine 0 degrees, you're going to tell me what's the x-coordinate? 1. You just told me cosine 0 degrees. Okay? So for input 0, I get an output 1. And so it's like I have a y-intercept of 1. Okay, let's move to the next quadrantal angle. And Keegan, give me cosine 90 degrees. 0. That's the x-coordinate for that angle that goes straight up the positive y-axis. So if I input 90 degrees for theta, I get an output of 0. Kennedy, what about cosine 180? -1. Okay, so when I input the negative, or the 180 angle, I get an output of -1. Dalton, what about cosine 270? 0. All right. And Abigail, what about cosine 360? 1. So now we're back to where we started, and we will start repeating. So we've been through one cycle. So my cosine graph in general looks like this. Now something that you do not want to do, you might think, well, what's the big deal? Well, notice, just like sine, our y coordinates never go above 1 and they never go below -1. So I've already seen some people, when we've been practicing, they're doing stuff like this. You know, they're coming through this point and then they're just going forever. Well, that shouldn't happen because 1 is the peak. And we don't go any further than 1 and we don't go any below -1. So be careful that you make sure you show that on your graph. All right, so once again, very much like sine, the graph's a little different, but all these particulars are the same. We still have all real numbers for the domain. Any real number input is fine. The range, just like sine, is y such that we're between -1 and +1. Amplitude is 1. Period, again, 360 degrees. We will start repeating the cycle after 360. Any questions so far? Got a unit circle. These are pretty easy. Well, tangent's quite a bit different. So let's sketch a graph of tangent, the parent. We'll use these same quadrantal angles. So these are theta inputs, y outputs. Well, right off the bat, if you're looking at the unit circle, you should know already at certain ones of these, tangent isn't even defined. What degrees? It's okay at 360, but there are certain places. Okay, at 90 degrees, if you do y over x, which is what sine is, or what tangent is, then that's dividing by 0, and that's not allowed. So we're going to have to draw out our old friend vertical asymptotes, because the 90-degree angle isn't allowed. That would mean division by 0. And that also occurs where? 270. If you go down to the 270 degree and you do y over x, which is tangent, the x is 0, you're dividing by 0 and can't do it. Okay, well for these others, like tangent 0 degrees, what's that? 0. And what's tangent 180? 0. And all the way around, tangent 360, still 0. So by definition of vertical asymptotes, we've had a lot of experience with these. We know we're going to be going through these points on this theta axis that I've marked, 0, 180, 360, and then we're just going to follow the vertical forever and ever going up, but we're never going to touch. And that would happen over here as well if I had drawn -90. So tangent does this kind of shape. There are certain places starting at 90 and then plus 180. Every time we go plus 180, we'll have another vertical asymptote, but in between we will do this. And it's just repetitious, periodic. So let's see how it's different with these particular items. For example, domain. Well, obviously, we can't say all real numbers because we've identified 2 of the infinite number of numbers that are not allowed. So we're going to say the domain like this. We're just going to say what x can't be. Well, first of all, it can't be 90. And I don't want to make a list. I don't want to say 90, 270, 450. We could do that all day and we never stop. So we're going to say it like this. Adding 180 times some number n, some integer. So what if I let n be 0? What do I have? 90. What if I let n be 1? 270, and you get the picture. So this is a better way of expressing starting at 90 and then increasing by 180 every time to get to that next vertical asymptote. Okay, now the range is different also because you can see that as we travel along the y-axis, we're going forever, both positive and negative. So the range for this tangent function is all real numbers. The tangent function does not have amplitude. That probably makes sense because if we're traveling forever and ever, both positive and negative, along the y-axis, we don't have a high and a low. That's what amplitude does for us. So there is no amplitude for the tangent function. And what do you think the period is? Okay, and in particular, the period is the horizontal length of a cycle. So what is that horizontal length of where it repeats every time? Looks like it's 180 because within these 2 vertical asymptotes, between 90 and 270, that's 180 degrees, and that's going to happen again over here. So unlike sine and cosine, the period is different. It's 180 degrees. Okay, so now we're going to take these basic parent functions and we're going to transform them. Adjust their amplitude, adjust the period, and I'll show you how to do that. All right, so in general, notice I've included this number a that we've actually already talked about, and I'll mention it again. And then here's another number that I've labeled as b. How does that affect our graph? So your directions for all problems that you're going to do are right here. So you're going to be asked to find the amplitude, find the period, and then sketch the graph. You will need to draw this on all of your graphs. Just make that as big as you need for it to be, but it's going to look something like this. Okay, let's start with the amplitude for letter A. Well, I mentioned earlier the amplitude is the absolute value of whatever is being multiplied by sine or cosine, and in this case that's 4. The reason why we say absolute value is because eventually you're going to see this. Now, that's a negative 4. What does that do to the graph based on your past experience? It flips it. The negative number here always reflects over what we would call the x-axis. But the amplitude we wouldn't say is negative 4. The amplitude would be the absolute value of negative 4, which is positive. Okay, so we've taken care of amplitude. Here's how you find the period. I'm going to do it in general, and then this is specific. The period is always 360 degrees divided by whatever this b number is. So for this particular case that we're about to do, it's understood that b is 1. So my period in the problem I'm about to do is just 360 degrees. The graph interval is something that your book doesn't do. So if you're one of these people that you like to go back and read the chapter, I mean, it's good, but I think it's a little bit confusing personally, but you're welcome to do what they do. I'm going to show you graphing these a little differently than the book does. But the graph interval is what we're going to use, what units we're going to use on this horizontal axis. And it's pretty simple. Just take whatever you got for the period and divide that number by 4. So for us, in this particular problem, we're going to do 360 divided by 4, and we're back to that 90 degree, 180 degrees, like we did before. And since I've already established that in this problem the amplitude is 4, I'm just going to make this become positive 4, and this will become negative 4. And we're ready to graph. So it's like inputs, and every one of these starting with 0 becomes an input for theta. And you can use your unit circle to come up with the results. So I'm going to start with angle 0, and I'm going to do sine 0, which is 0. And now it's like doing 4 times 0. 0, okay? So the result of inputting 0 in for theta gave me an output of 0. Okay? Input 90 in for theta and do sine 90. And we've been through this already. Sine 90 is 1. And now it's 4 times 1. 4 times 1 is 4. Back to 180. Sine 180 is 0. 4 times 0 is 0. Sine 270 is negative 1. And so we'll do 4 times negative 1, which is negative 4. And then when we're back to 360, sine 360 is 0. 4 times 0 is 0. And we're ready to draw the curve. And that would be, if that were a homework problem, that would be your complete answer. State the amplitude, state the period, and then draw the graph. Any questions? No questions? All right, let's try another one. Letter B. Okay, so the amplitude. The amplitude will be whatever this A number is, something being multiplied in front of sine or cosine, and that's understood to be 1. It's the absolute value of that number. The period is 360 degrees divided by this number that we call B. So 360 degrees divided by 3 is 120 degrees. So another way of saying that is this number should tell us how many times a cycle is completed within the 360 degree circle. And when we're done, we should see the cycle being finished 3 times. All right, and the graph interval, our units will be made up of 120 degrees divided by 4. So we're going to do graph interval units along this horizontal axis every 30 degrees. Until we get to 360. So let's start. It's always divided by 4. Just think we're dividing, just like the unit circle is divided up into 4 main parts. So we're going to squeeze in, you can go ahead and get ahead of me, we're going to squeeze all these in. Every 30 degrees. Yeah.
And every time we do the graph interval, we want to get a 360?
Yeah. Now you might have to go more than that in cases like when this is a fraction. It's like a cycle is only completed halfway around, so you'll have to go up to 720 to get the full cycle. Okay, amplitude 1, so we can put positive 1, negative 1. And really, once you've gone through one cycle, you just repeat that, in this case, 2 more times, and you'll have the graph. So let's start at 0 degrees. When we input 0 in for theta, it's like doing 3 times 0, which is still 0, and then we do sine 0, which is 0. So these numbers on your horizontal axis are replacements. They're inputs for theta. They're degree measures. Okay, let's go to 30 degrees for theta. So it's like doing 3 times 30. You're really doing sine 90 degrees, which is 1. So for 30, I'm going to jump up to 1. Sine 90. Well, you put 30 in for theta, but then you're doing 3 times 30. Everybody see that? Okay, what about input 60? You're really doing 3 times 60 according to this, which is 180. And what's sine 180? 0. Okay, when you input 90, you're doing sine 270, which is negative 1. When you input 120, you're doing sine 360, which you're back to 0. So we said that one period should be 120 degrees, and that's exactly what happened. So I'm going to try to connect these. Skinny. All right, so that's one cycle. Period would be the horizontal length, 120 degrees. So really, to finish this off, you just need to repeat this 2 more times, and you'll be done. So go ahead and do that. I'll just walk around and make sure you got it right. You guys are doing good. Okay, who has a question? Do you think you get it so far? Starting off really basic. The amplitude. Okay, so that's our completed graph for this sine function. Let's take a look at another one. This is cosine. So once again, we're supposed to identify the amplitude, and the understood number in front of cosine is 1, so we can go ahead and mark positive 1 and negative 1 on the y-axis. The period is always 360 degrees divided by this number called b. It's some number being multiplied by theta. And so in this case, the period should be 180 degrees. Or in other words, we should see 2 complete cycles by the time we get through the full 360 degrees. And the graph interval will be that period number divided by 4, so that's going to be 45 degrees. So we're going to do our horizontal axis in increments of 45. Yes. Always divided by 4. Okay, so we're back to what we were doing before. We start at 0 degrees, which is here. And I'll let theta be 0. 2 times 0 is still 0. Cosine 0 is 1. If I input 45, I get 2 times 45, which is 90, and cosine 90 is 0. If I input 90, cosine 180 is -1. If I input 135, I'm doing cosine 270, 2 times 135. And cosine 270 is 0. You can just verify that on the unit circle if you're not sure. And when I go to 180 times 2, that's 360. And now I'm all the way back. I've completed one cycle, which I already knew that one period was 180 degrees. So now I just need to repeat those dots again to create that same pattern. And I will have my final graph. Connect the dots. And yours will be a lot better than mine, probably. Any questions? So far, so good? I think I just have one more. I had more planned, but first period we didn't get to the tangent, so I'm going to reduce your assignment by 2 problems in the end. So Meredith, give me the amplitude here. 1/2. So we can go ahead and label positive 1/2 and negative 1/2. Let's see. Matthew, give me the period. Okay, that's 360 degrees if you're not sure how you got that. 360 degrees divided by this number being multiplied by theta. So that's 120 degrees. And what's our graph interval, Kennedy? 30 degrees. And how'd you get that? 120 divided by 4. Okay? Okay, so we've got our horizontal axis. These are all degrees representing inputs for theta. This is my vertical axis, the y. I didn't finish putting all degrees. Let me just go ahead and do that real fast. Make this more complete. And now we just start with 0 degrees. And we'll do 3 times 0, which is 0. Cosine 0 is 1. And 1 times 1/2 is 1/2. So for inputting 0, I get output 1/2. For inputting 30 degrees, you can think 3 times 30, which is 90. Then you're doing cosine 90, which is 0. And 0 times 1/2 is still 0. Let me erase this so that we won't think it's a point. All right, let's move to 60 degrees. 3 times 60 is 180. Cosine 180 is -1. And 1/2 times -1 is -1/2. And then we're back to 90 degrees. 3 times 90 is 270. Cosine 270 is 0. 1/2 times 0, also 0. And then 120, which should be the end of our cycle. That's 3 times 120, which is 360. Cosine 360 is 1. And 1/2 times 1 is 1/2. All right, so sure enough, we have completed one cycle. And according to this, there should be 3 of these cycles contained in one complete revolution around the unit circle. So all we really have to do at this point is show this same pattern being repeated. All right, so the next point would be here, then we go down to here, back up to here, and then that's another cycle. So this would be, the green would be the second repetition. And then we'll just do this one in red. We'll do that same thing again. So we're here at 240, completion of pattern number 2. So we'll drop down to 270, down to 300, back up to 330, back up to 360, and it's going to turn from there, of course. We can't go higher than 1/2. And so that would be good for the graph of this particular function. And that's going to close out as far as we got today. We will eventually cover tangent, but for now you can just think about doing sine and cosine graphs. So I'm going to eliminate these last two, which were tangent graphs, for this particular assignment. And after this next test, we'll come back and take a look at tangent graphs as we have time. So let me know if I can help you.